Hello everyone, you're welcome to Mathematics Tour. This is the Cambridge IGCSE Mathematics written in May-June 2024. This is variant 2.1 for extended student, that is paper 2. There are 22 questions in this paper. If you are seeing this channel for the first time, please kindly subscribe to my YouTube channel by clicking the subscribe button, like, comment, and share this video. Let's jump into the first question. Question 1. The diagram shows two sides of a parallelogram A, B, C, D. Find the coordinates of point D. If you look at the diagram very well, so you already have one side here, another side here, so we need to draw the corresponding parallel sides for each of these two given sides. Okay, so if you look at this side, for instance, BC, so from B you have 1 2 3 4, then 1 2. So from here, if you count 1 2 3 4, okay, then count 2 up, 1 2, so you have a point here. Okay, so point D should be here, so you can easily join the points together from A to D, for instance, and you could join DC as well. Okay, so this is the parallelogram you get when you put the point here. So this side and this side are parallel, while this side and this side are also parallel. So that will be the location of point D. X equals to -3 and y equals to +7. So let's put the answer here, -3 against +7. Question 2. Geetha has a box of toys. She picks a toy at random from the box. The probability that she picks a wooden toy is 0.6. Work out the probability that she does not pick a wooden toy. Okay, so these are mutually exclusive events. So it will be, they add up to 1. Okay, so you have 0.6 plus the probability that she does not pick a wooden toy equals to 1. So that means the probability that she does not pick the wooden toy will be 1 minus 0.6, and that will be 0.4. Part B. The box contains 3 types of toys: wooden, plastic, or metal. So you have the given table, complete the table. Okay, so don't forget that the probability that she does not pick a wooden toy is 0.4. So that means this and this should add up to 0.4. Since they have the same number of toys, then they are equal, so you can easily divide this into 2 because they have the same probability. They have equal chance of being selected. Okay, so we have 0.2, 0.2, and everything should add up to 1. Fine. So the last one here, the number of toys, so for wooden, okay, so that are wooden. So what you need to do here is to say, take for instance, the probability of the plastic is given as 0.2. So be equals to number of plastic is 14 over total, so which we want to get now. So we can get the total from here. So if you make the total the subject of the formula, so the total will be equals to 14 divided by 0.2. So if you do 14 divided by 0.2, so that will give you 70. Okay, so from here we can now subtract 14 and subtract 14 again, that is subtract 28 from 70, so that will give you 42. So that means the wooden toys are 42. Okay, so good. Let's go to the next question. Question 3. The table shows some information about two sequences. You have them here. Complete the table. So for the 5th term, we pass in 5 into n here, that is 60 minus 4 into 5. Okay, that will be 60 minus 20, so you get 40. And here you pass 5 into n here, so that will be 5 squared, 25 minus 300. So if you do this, you should get a negative answer, that is minus 275. So you have completed the table. Part B, find the smallest positive number in the sequence B. Okay, so what you can do here is very simple. Since we have 300 here, okay, so let's take, if you find square root of 300, that will give you 17 point something. Okay, so that means the value of n that will be very close to this one to get a positive number. So it will be, this will be 17 point something something here. Okay, so that means we need n to be equals to 18. Okay, so that is where we can get a positive, the smallest positive number there. So if you do 18 squared, then minus 300, so this should give you 324 minus 300, so and you have 24 here. Okay, so that is what you need to do, because you need a number that is a little bit more than the square of this, the closest perfect square to 300. Okay, so you need a number that is bigger than that. Okay, so I have a positive number there. Okay, for number 4, find the greatest odd number that is a factor of 140 and a factor of 210. So you can use downward division for 140. So you can easily divide. 2 goes here 70 times. 2 goes in 70, 35. Then what can go? 5 here, 7, 5, 7 in 7. We have 1. So for 210, so you can use downward division as well. So you have 2 here, that will be 105. 3 can go, 3 here, you have 3, 5, that is 35. You have 5 here, that is 7. You have 7 here, that is 1. So you have 35 here, 35 here. So the answer here is 35. Question 5a. So you are asked to do this. So this is pretty easy. You can easily input this into your calculator. So you can easily input this into your calculator. So this is my calculator here. So we need cube root. So you press shift, then cube root should be here. Okay, then we have 3, 4, 3, 3, 4, 3, then minus, then we need to jump out of that square root. Okay, so we need cube root rather. So we need square root now. So this will be 40.96. Okay, then you hit enter. So you have your, oh sorry, there should be an error there. Oh sorry, so I should separate that the sign of subtraction there. Okay, so there should be space there. Okay, it should be out of that. Let's see, is it okay now? So okay, so it's pretty okay now. So you have 3 out of 5. So that is the answer, and you can leave your answer to a decimal number if you want to do that. That would be 0.6. Okay, so another thing is to, okay, you can get the conversion from your calculator, but it's pretty easy. So you can either write 3 out of 5 here, or you just write 0.6. So I'll write 0.6 here. Okay, so we have another one here. So this is 192 add 4 multiplied by 16 to the power of 1.25. So you could as well use your calculator again. So let's pick the calculator again. So you have this. So let's rub this. So this will be open bracket. You can just insert it the way it appears here. That is 192, then add 4. Then multiplied by 16, bracket closed, then raised to the power of 1.25 like this. So you hit enter, so you should get the answer straight away. So that is 1024. So 1024. So that is pretty easy. So let's go to the next question. Question 6. The diagram shows 5 kites that are congruent to kite A, B, C, D. Each kite is joined to the next kite along one edge. Angle DAB equals to 40 degrees and DCE is a straight line. Find the value of x. Okay, since they are congruent, so x will be here, it will be here, it will be here, it will be here. Okay, so it means they are equal. Okay, so that is the implication. Okay, so let's find the value of angle x here. Okay, so the first one, and you can also take these two to be angle x2 because these two sides, these two angles are equal. So there's something here. The sum of angles here add up to 180 degrees because they are angles on a straight line, and I can easily find one because we have 1, 2, 3, 4, 5, 6. So that means each angle here will be 180 degrees divided by 6. That will be 30 degrees. So that means here is 30, 30, 30, 30, 30, and 30. So that is what we have there. They are congruent. Okay, and we know that this angle, so this will be x. So this place too will also be x. So these two angles are equal. So I can place x here all through. Okay, so because they will have the same angle as they are congruent. So here too will also be x. Okay, so that is the implication. So I know that the sum of angles in a kite or in any quadrilateral is 360 degrees. So these two angles add up to 70 degrees. So that means I can say 360 degrees minus 70 degrees. Okay, so that will be 290 degrees. Okay, so that means these two angles have to share 290 degrees. That is x add x, that is 2x. So these two angles add up to 290 degrees. So that's the meaning of this expression. So I can say x equals to 290 divided by 2. So that will give me 145. So each of these is 145 degrees. So I can just scroll down and write 145 degrees here. Pretty simple and straightforward. So let's go to the next question. That should be question 7. The diagram shows a shape made from a triangle JKL and a semicircle with diameter JL. JKL is an isosceles right-angled triangle with JK equals to JL equals to 12.8 centimeters. Calculate the area of the shape. Okay, so the area of the shape will be area of this triangle plus the area of this semicircle. So the area of the triangle will be base times height divided by 2. Okay, and the area of the semicircle will be area of a circle divided by 2. So let's quickly do that here. So for the area of the triangle, it will be base times height over 2. So that will be the base. This is the base, 12.8 centimeters, and the height is also 12.8 centimeters. So you can have 12.8 centimeters times 12.8 centimeters. So I can equally write 12.8 centimeters squared. It's 12.8 squared. Okay, so I can easily write that too, but no troubles. We can write it like this. So if you divide this by 2, okay, so this will give us 81.92. That is the area of the triangle. Then we need to get the area of the semicircle. Okay, so this is my first answer. So the area of the semicircle will be area of a circle divided by 2. That is pi r squared over 2. Pi is 3.142 multiplied by the radius. So let's scroll up. The radius is half of 12.8. That will be 6.4. So you have 6.4 squared over 2. So this will be the area of the semicircle. So you can input this into your calculator straight away and you should get 64.3482. So this is my second answer. So when you add the two together, that is 81.92 add 64.3482. So you should get 146, correct, to 3 significant figures. Okay, part B, calculate the perimeter of this shape. So the perimeter will be this side, add this side. So let me remove this. So add this side, So we have 3 sides, okay? This side, and this arc, okay? So we need to add these 3 things rather, okay? This arc, okay, or the circumference of a semicircle, and this side as well as this side. So we already know that this is 12.8. So I need to find KL by using Pythagoras theorem, and also I can find the circumference of a semicircle. Okay, so let's scroll down and do that. Okay, so for the this is the hypotenuse. It will be square root of sum of the square of this and this. Okay, so let's scroll down. Then we can have KL to be equals to square root of, okay, let's write this, 12.8 squared plus 12.8 squared. So it will be in square roots. Okay, so if you input this into a calculator, you get 18.1019. So you don't need to waste your time. Okay, so equally, we need to get the circumference of a semicircle. So can I scroll down? Let's see. Okay, good. So the circumference. So the circumference of the semicircle, so will be equals to circumference of a circle, which is 2 pi r, and divided by 2. Okay, so 2 will cancel 2. So I just have pi r. So that will be equals to 3.142 multiplied by the radius. So the radius is 6.4. Okay, so that is what you need to do. So now we need to add the 2 answers together. Let's firstly write this answer. This will give us 20.1088. Okay, so we know this, that's circumference. So we can now add the 3 sides together. So that will be 12.8, add the answer we got here, that is 18.1019, okay? And the answer we just got here, that is 20.1088. So the perimeter of the shape will therefore be, that's 20.1088 plus 18.1019 plus 12.8. So everything should give you 51. So you have 51 here. So pretty easy as well. Question 8. These are the first 5 terms of a sequence. Okay, if you check the 10 to 10 rule, that is subtract 7. Okay, so that is 7, 7, 7, and 7. Okay, so find an expression for the nth term of the sequence. So let's say the nth term is equals to, the common difference will be 7, then multiplied by n, 7n. So if our nth term is this, let's check. So first term will be 7 times 1, that will be 7. So that means we are short of 4. Okay, so when n equals to 2 for the second term, it will be 7 times 2, that will be 14. So we are short of 4 again. Okay, so I think this is okay. So for this to be our n term, so you need to add 4. Then it's very okay. So let's take the third term, for instance, when n equals to 3. So 3 times 7, that is 21. 21 add 4, that is 25. So pretty correct. So this is 7n plus 4. Question 9. The value of a car is $8,000. Each year, the value of the car decreases exponentially by 25%. So calculate the value of this car after 3 years. So this is exponential decay. So using y to be equals to ab to the power of x. So here a is the current value, that is $8,000, and b will be equals to 1 minus r because it is exponential decay. Okay, so our r here is 25%, that is 0.25. So this will be equals to 1 minus 0.25, and that will be equals to 0.75. So that is what we have for the value of b, and x is the number of years, which is 3. So if you key in this value, you have y to be equals to 8,000 into 0.75 to the power of 3. If you input this into your calculator, you should get $3,375. 3375. Question 10. Amir invests $1,500 in an account. The account pays compound interest at a rate of R% per year. At the end of 8 years, the value of his investment is $1,656.73. So find the value of R. Okay, so from the formula of amount, we know that amount is equals to the principal into bracket 1 plus the rate over n, that is the number of times the interest is paid in a year, the power of nt. So the amount is given as 1,000, that is 1656.73, and the principal is 1,500 into 1 plus r. So the interest is paid once in a year, so n equals to 1. Then you have 1 times 8. So from here we need to solve for r. So but we can easily divide both sides by 1500. So 1500. So this will eliminate this. So we are left with 1656.73 over 1500 to be equals to 1 plus r to the power of 8. Okay, so what we can do here, so we can put bracket here. So we want this 8 to go, so we need to multiply by the inverse, that is 1 over 8. So the power 2 by 1 over 8. Okay, so this will go. So you can actually input this into your calculator and you get the answer straight away, the way it appears here. So let me show you that. So we can just do this. Okay, so let's get the calculator. So this, we need to open a bracket. Okay, then we need a fraction. So we have 1656.73. okay, then we need to come down. So we have 1500. Then we need to close the bracket. Then we need power. So let's take this. Then we need fraction again. So this will be fraction. That will be 1 of 8. So that's the power. So if you hit enter here, so you get your answer. So you have 1.0125. okay, so 1.0125, okay, to be equals to 1 plus r. So from here we can easily solve for the value of r. So that will be 1.0125, okay, minus 1 equals to r. So that will be 0.0125 equals to r. So we need to multiply this by 100%. So it will be 0.0125 multiplied by 100%. Okay, so the value of r will be equals to 1.25%. okay, so you have 1.25%. so that is the value of r. So let's go to the next question. So this is question 11. Find the inequalities that define the unshaded region R. Okay, so let's start with this one here. So this is a thick line, so that is equals to should be there. So that is y. greater than or equals to 1. Okay, so that's for this thick line here. Okay, so how do you know that it's greater than? You see from here y equals to 1, so if you go up, so y increases. Okay, so that is why it is greater than, and it is equal to because you have a thick line here. Okay, so this is 1. So let's take these two again because we have a boundary here and interval. So here we have y, so it's also a thick line, so we're going to see equal to and less than, because from here if you come to the unshaded region, the value of y decreases, so this will be y less than or equals to 5. Okay, so it is equals to 5 because of this thick line, and it is less than 5 because the value of y decreases as you move to this region. So now we need to combine these two inequalities together, because if you say y is greater than 1, okay, it means you have 1, 2, 3, 4, 5, 6 up to infinity, but it's not like that. It's ends here. Okay, so that means you can say you can combine these two to be 1 less than or equals to y, and y is less than or equals to 5. So this is what we should write. Okay, not these two separately. Okay, so we have 1, so that means we've taken care of this and this, so we are left with 2, the broken lines. So for this one, x equals to x is less than 6. Okay, because from here is the value of x here is 6, but it's not equals to 6 because of this broken line. Then if you come here, the value of x decreases, so you just have x less than 6. So this will be the second one, and the last one will be this. Okay, so if you look at this now, it comes here. Okay, so it means it passes through the origin, so the intercept on x-axis, on y-axis rather, is equals to 0, so equals to 0. So we are left with y equals to mx. Okay, so if you look at the gradient, for instance, from here, so you run you jump once, okay, and you run forward once. Okay, 1 1 1 1, so the gradient equals to 1 over 1, okay, x. So y is equals to 1x, which is equals to y is equals to x. Okay, so this is what you have here. So you have y equals to x, so this is this line, and of course if you are conversant with the diagram, okay, so if you have something like this is y equals to x. Okay, and if you have something like this, okay, something like this, y equals to x, and if you have it like this, y equals to negative x. Okay, so that is pretty easy. So but we have a broken line here, so that means there's no sign of equality there. So if you look at a point here now, so instead of y equals to x, so we should either have y less than x or y is greater than x. So let's see, if we take a point inside the unshaded region, for instance here, so from x equals to 1, so it will be x equals to 4. Okay, and y is so here y is equals to 1. Okay, so let's come here again. So x equals to 4, y equals to 3. Okay, so okay, if you take this point, for instance here, x equals to 4 and y equals to 2, so you can see that y is less than x, so that's it. Let's take another point here. Okay, so sorry, it should be on this line here rather. So yes, I think that's correct. Okay, let me undo that. That's correct. So if we pick another point here, so that would be x equals to 5 and x equals to 3. You can see that y is always less than x, but if you try to take a point here, so you see that x equals to 2 and y equals to 6. So for this one now, the unshaded region, y is less than x. So that is what we have here. So this and these are our answers. So let me write them. So this is the first one, number 1. This is the second one, and this is the third one. So I'll write for this one, that is 1 is less than or equals to y, y is less than or equals to 5, then another one, x is less than 6, then the last one, y is less than x. Okay, question 12, solve the simultaneous equations. You must show how you're working. So if this is equation 1, okay, so let's write this by multiplying each of these each of the terms by 2, that is 2 times this, 2 times 5y, 2 times 5, so linearize it. So that will be 3x plus 2 times 5y, 10y equals to 10. So I can call this equation 1 now. Okay, so this and this are the same. So I just wrote this in, I just linearized this to this, okay? So equation 2 will be 4x minus 3y equals to 46. Okay, so using elimination method, so I have to make the coefficient of x to be equal. So I'll multiply equation 1 by 4. So that will be 3 times 4, 4 times 3x, that will be 12x, plus 4 times 10y, that will be 40y, equals to 40. So I can call this equation 3. Then let's multiply equation 2 by 3. So that will be 12x. So negative 3y times 3, that will be negative 9y, then equals to 46 multiplied by 3. So if you do this 3 times 6, 18, you write 8. So you carry 1, you keep 1. So 3 times 4, 12 plus 1 you grab, that is 13. So 138. So I can call this equation 4. Okay, so I can now eliminate these two equations. I can eliminate x from these two equations 3 and 4. Okay, so let's rule a line here. Okay, so let's scroll up a little bit. Okay, so here minus we do the work for me. So this and this minus this, we have 0 here. So these two signs will combine together to become positive. So that is, I should have 49y equals to negative 98. So if I divide both sides by 49, okay, so this will cancel out. So y should be equals to negative 2. So I have negative 2 here. So I can substitute the value of y into any of the equations 1, 2, 3, and 4. So let's use equation 1. So that will be 3x plus 10 into y is negative 2 equals to 10. That is pretty easy. 3x minus 20, if we expand the bracket, equals to 10. 3x equals to 10, add 20, 3x equals to 30, x equals to positive 10. So x equals to positive 10 when y is equals to negative 2. So let's go to the next question. That will be question 13. So here the diagram shows a cyclic quadrilateral. Find the value of p. So one of the theorems of a cyclic quadrilateral is that opposite angles are supplementary. That is, they add up to 180 degrees. Okay, so for these two, I will say 4m add 5m equals to 180 degrees. That is 9m equals to 180 degrees. M equals to 180 over 2. That will be 20. Okay. So similarly, these two angles, okay, this and this, so that will be P add 4m plus 38 equals to 180 degrees. So P plus 4 into m is 20, so let's substitute that, plus 38 equals to 180 degrees. So if you expand this bracket, so 4 times 20, that will be 80 plus 38 equals to 180 degrees. So I can just, can subtract everything directly. So P will be equals to 180 minus 38 minus 80. So So the value of P should be equals to 62 degrees. So that is pretty straightforward, 62 degrees. Let's go to the next question. That is question 14. The diagram shows a circle with radius 9 centimeters. Calculate the area of the shaded major sector. So we need this reflex angle, okay, and that will be 360 minus 48 degrees. So that will be 312 degrees. Okay, so the area will be equals to theta over 360 times pi r squared. So this will be equals to 312 over 360 multiplied by 3.142 multiplied by the radius remains 9 squared. So you can actually input the whole of this into your calculator and your answer should be equals to 221, correct to 3 significant figures. Question 15, write 0.146 recurring decimal as a fraction in the simplest one. You must show how you're working. So you know this is the same as 0.1464646 and so on and so forth. Okay, so it means 4 and 6 keeps on 4 and 6 keep on recurring. So I can say x, let x to be equals to 0.146 recurring decimal. Call this equation 1. So I need the recurring digits to come immediately after the decimal point. So for that reason, I need to multiply equation 1 by 10, okay, to shift the decimal point. So if I do that, that means equation 1 will become 10x to be equals to 1.46 recurring decimal. So I can call this equation 2. Then the next step is to multiply equation 2 by 100 because we have two repeated digits. So if I do that, it will be 1000x to be equals to, so 1, 2, the decimal point will come here. So you have 146 points. Don't forget, 4 and 6 keep on recurring. So I can just put 4 and 6 here as recurring digits, okay? So you can call this equation 3, then subtract equation 2 from 3. So you can do 3 minus 2, okay? So 1000x minus 10x, so that will give us 990x, okay? Equals to, if you do this, subtract minus this, so the decimal point and any other digit there will cancel out. Okay, so we have 146 minus 1, that is 145. Okay, so we cannot divide both sides by 990. So x will be equals to 145 over 990. So if you divide the numerator and the denominator by 5, so that could be simplified to 29 out of 198. So you have 29 out of 198. Okay, so pretty straightforward when you follow the steps. Question 16a. In the Venn diagram, shade the region not in M and not in N. So it will be outside the two circles. Okay, so we can easily shade the whole of this. Let's come like this. Pick this one again, sorry, in case it goes out, so it may not be actually perfect. Okay, so we just have to shade inside the rectangle but outside the two circles. So we can just take this like this. Okay, so we take this like this. So you need to shade everything. Okay, like this. Actually, it's somehow fun. Okay, so do this. So just have to do this one too, like this. Okay, like this. Oh, okay, I think I can Sorry, I'll remove that later. So let's just do something like this first. Okay. Okay. So I'll remove the unwanted area later. Okay, so just to ensure that everything is okay, good. So good. Let's come here. Okay, good. Okay, so I can now remove the unwanted side there. So I don't need to shade the circle at all. Okay. So let's remove this. Good, 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 good. Okay, let's take this again. Okay, so I think it's a little bit better now. So you don't have to shade the circle, so that is all what you need to do, just outside the circle but inside the rectangle. Okay, so I think it's pretty okay like that. So let's go to part B. Here, find this. So here too, you need to be very careful. Okay, in order to shade, find the number of you need to find the number of elements in this set. Okay, but let's start with the C first. So shade the whole of C. So the whole of C will be this. I think I can do something like this. So from here, so this will be the whole of C from here, something like that. Okay, so I will leave the numbers for you to see the numbers clearly. Okay, so but you have to shade the whole of C, for instance. So this is just a trick I use to get the answers. So I have 10, 18, 9, and 4 there. So let me see if I do this to cover it. Okay, so let me undo it. So I have C, then combine C with regions that are out of A. Okay, so that means I need out of A, so I need to shade this like this. Okay, so I will leave the number for you to see it clearly. Okay, so I need to shade this. Then I need to shade the whole of the rectangle that is outside the 3 circles. Okay, sorry, I have to shade the whole of this. Okay, something like this. Okay, so to make it faster, so these are the regions that are not in A. Okay, that is part of B and the whole of outside the 3 circles. Okay, so that is A complement. Okay, regions that are not in A, that is A complement. Now, so what I have now is A complement union C. So the shaded region, okay, is A complement union C. So I need where that region, okay, intersects B. Okay, so you see that it will be here we have the blue part here in B. Okay, so we need the blue part in B. So we have 10, we have 4, and we have 3. Okay, so you can see that 16 is also in B, in circle B, but there is no blue part there. Okay, so the answer here will be equals to 4 plus 3 plus 10. Okay, so that's what we need to have here. So that will be 17. Okay, so that's just the trick I used to get my answer anytime it comes to Venn diagram. Okay, so question 17. Calculate the area of triangle ABC. So we have 2 sides and an angle between them. Okay, so this is pretty easy. So you don't need to write down the formula once you know how it operates. Okay, because anytime you are given a triangle like this, you have a side here A, you have a side here B, okay, and you have theta here. Okay, so the formula is just the product of the 2 given sides multiplied by the sine of angle between them. Okay, between the given sides. so divided by 2. Okay, so pretty straightforward. So if you are given other angles, so you must find the needed or the required angle. So this one, I have this side, I have this side, and I have an angle between them. So everything is okay. So I'll just say the area will be equals to 6.7 multiplied by 5.9 multiplied by sine of the angle between them, 81. Okay, everything divided by 2. So when you input that into your calculator, you should get 19.5 straight away. Okay, so no need to waste time here. So let's go to the next question. That will be question 18. So here, by the diagram shows the graph of that expression for the given range. So by drawing a suitable straight line, solve the equation this. Okay, so this is equals to y. The whole of this is equals to y. So that means y is equals to 2x. So that is the line we need to draw. So if you look at y equals to 2x, so there's no intercept on y-axis. That means it passes through the origin, and the gradient is 2 over 1. Okay, so you go up twice and you move forward once. Okay, so from here, from 0, you go up twice, then you move forward once. So a point will be here. Okay, then from the origin again, if you go down twice and you move backward once, so it will be here. So I can just connect these 2 points together. Okay, and that will be my straight line. It passes through the origin. Just have it like this. Okay, I'm good to go. Okay, so I need the reading here and here. Okay, so that will be the solution. Okay, to this. So if you look at this, this is negative 0.5. And if you trace this one down, it is here, it is positive 0.9. So let's come here, x equals to negative 0.5, or x equals to positive 0.9. Okay, good. So let's go to the next question. That's question 19. Factorize completely this. So first of all, 3 can go here. So you have 3 into 4m squared minus 75 divided by 3, that will be 25 into t squared. So I can write this as a difference of 2 squares. So it will be 3 into, but before then it will be 4 is 2 squared. Okay, 2 squared m squared minus 5 squared t squared. So instead of having repeated square, so I can just combine them. 3 into 2m, so all squared, minus 5t all squared. So I have difference of 2 squares. So my final answer will be 3 into, so this will be equals to 2m minus 5t into 2m plus 5t. So that's the answer. 3 into 2m minus 5t, then 2m plus 5t. Okay, then part B, factorize this completely. So if you look at this, I can actually bring this and this closer. So it will be xy plus 5x. Okay, then these 2 plus 3y plus 15. So here, x is common. So I'll be left with y plus 5. Plus here 3 is common, I'll be left with y plus 5. Beautiful. So I now have x plus 3 for the outside terms. Then let's just pick one of these into y plus 5. So x plus 3 into y plus 5. So question 20, solve the equation this. 8 sine x plus 6 equals to 1 for this given range. Okay, so it will be 8 sine x equals to 1 minus 6. So that will be 8 sine x equals to negative 5. Then sine x equals to negative 5 over 8. Okay, so that will be sine x equals to, this should give, okay, let's leave it as a fraction like that. as negative 5 over 8. Let me leave it like this. So I'll find sine inverse of both sides. So it will be x equals to sine inverse of negative 5 of 8. So x will be equals to negative 38.7 degrees. Okay, so but x can never be this because it's outside this range. Okay, so we need positive numbers. So let's draw the 4 quadrants. All students take calculus. Okay, so currently we got 38.7. So that's negative 38.7 rather negative. Okay, so let's go to where sine is negative. Sine is negative here and here. Okay, so for that reason I'll draw a line here. Okay, so it will be here, that is negative 38.7 moving towards this direction. Ordinarily it should be like this, but since it is negative it will be like this. So this angle here is also 38.7. They are equal. Okay, so the answer I need to get is from here up to this line. That will be the first one. Okay, so that will be 180 add 38.7, which is 0.7. So that will be equals to 218.7. Okay, so the second one will be from here, okay, up to this line. Okay, so that will be 360. Sorry, there shouldn't be a negative sign here, just to show the direction of the angle. Okay, so it will be 360 then minus 38.7. So this will give us the second angle, which is 321.3. So these are the two answers, 218.7 and 321.3. Consider these two angles fall in the given range or interval. Okay, so that is pretty straightforward. So this is question 21, second to the last. Here the diagram shows a cuboid. HD equals to 4 centimeters, EH equals to 6.5 centimeters, and EF equals to 9.1 centimeters. Calculate the angle between CE and the base CDHG. So I can easily draw a line from here like this. That is CH. Okay, then I need the angle between them. This is theta. Okay, here, so I need this angle, which is theta. So this is a right angle here. So I can use SOHCAHTOA. Okay, so I need to find CH. Okay, so if EF is 9.1, okay, so HG will also be 9.1. Opposite sides of a rectangle are equal. Okay, then DC will also be, or CD will also be 9.1. So I can find CH now by using Pythagoras theorem. So that will be straightforward. CH will be equals to square root of 4 squared plus 9.1 squared. So if I input this into my calculator, I should get 9.94. So this place will be 9.94. Then I can now use this to get the angle, that is angle theta. So I can draw something here. Okay, let's say, okay, let me draw it out. You have this. Sorry, let's undo that. So I can draw this like this, then like this, and finally like this. Okay, so if we label it, so this will be E, this will be H, and this will be C. So this is the required angle theta. So here is 6.5, and I found this place to be 9.94. So I can use TOA, that is tan, opposite over adjacent. So from here I can say tan theta equals to our opposite, which is 6.5 over adjacent 9.94. So I can take tan inverse of both sides. Theta will be equals to tan inverse of 6.5 over 9.94. So you can do this directly you can input this into your calculator straight away, and you will get the answer to be 33.2 degrees when correct to three significant figures. Okay, so this is pretty straightforward there. 33.2 degrees. Okay, the last question. Bag A and bag B each contain red counters and blue counters only. Stefan picks a counter at random from bag A and Jen picks a counter at random from bag B. The probability that Stefan picks a red counter is 0.4. The probability that Stefan and Jen both pick a red counter is 0.25. And the probability that Stefan and Jen both pick a blue counter. Okay, so you can just do something like this. Let's say A against B. Okay, so this is Stefan, so I'll use S for Stefan. Okay, so I picks red. Okay, that will be 0.4 as given. So for blue, since they are both mutually exclusive. Okay, so this will be 1 minus 0.4. This will be 0.6. Okay, then here, let's come here for Jen. Okay, the probability of picking red. So the probability that Stefan and Jen both pick a red counter is 0.25. Okay, so this is independent. They are both independent events. Okay, so the result of this does not depend on this. Okay, so that is product. So that means the probability of A multiplied by A and B will be equal to probability of A multiplied by probability of B. So probability of red, both are red. Okay, that is A and B. Red is 0.25 equals to probability of red in A, that is 0.4, plus what? Red in B. Okay, multiplied rather, because they are independent. Okay, so let's divide both sides by 0.4 to get this. So if you do 0.24 divided by 0.4, you should get 0.625. Okay, so that means this place will be 0.625, and the probability for blue, okay, so this and this, they are mutually exclusive events. Okay, so it will be 1 minus 0.625 as the two add up to 1. So this will be 0.375. Now find the probability that Stefan and Jen both pick a blue counter to be this and this. So that is these two are also independent events, so it will be 0.6 multiplied by 0.375. So if you do this, you should get 0.225. Okay, so this will give us 0.225. This is the end of my solution to the Cambridge Igcse SE Mathematics Paper 2, Variant 2.1, written in May, June 2024. In the next video, I will solve the Variant 2.3. Until then, have your fingers crossed.